Bearing. When we talk of bearing, we note that mathematics is real and practical. We have some professionals that are using the knowledge of bearing in their professional works, such as navigators, geographers, pilots, technicians, and so on. Or the teachers to the student is also in a position of bearing. They are also in a position of bearing. And when we talk of bearing, we normally take the reading from the true north. What do we mean by true north? If the bearing is moving from a particular place, it has to go upward. Upward means it's going towards the north. And by the time you move to the north, you start your reading, and your reading must go clockwise, just like that of the watch. If you look at your watch starts from 12 and it has to go clockwise. You look at the minute hands, it will go clockwise. So the same thing is happening to bearing. On top of bearing, if you are given a problem to solve, say if the bearing of B from A is 65 degree, it can be represented by, when you want to draw now, you want to take the bearing of B from A is 65 degree. This is the bearing of B from A. It means you are starting from A. What we want to draw, you draw your bearing point like this, and then you are moving upward. This is the North Pole. 65, we are not expected to draw accurately, but here you can draw something to represent 65. 65 can be found in the first quadrant. You can find 65 degree in the first quadrant, which means it will move like this. And this is your position of your A. From A. From here, from the true north to this place, is your 65 degree. Now, this is position of B. This position of B. If you have to find the bearing of B from A, the bearing of A from B now will give us, it means you have to do the same thing here, showing us the true north. If the bearing of B from A is 65, what is the bearing of A from B? It means if you want to take the readings, it also starts from the north. When you are moving from the north, from here to here is 90, to here is another 90, making 180. Then what's going to be the value of this angle? This is where the manipulation will start. If this is 65, we believe that mathematically this angle is alternate to this angle. This gives us another 65. Then it means the bearing of A from B will be 180 degree plus 65, and this gives us 245 degree, which means the bearing of A from B will be equal to 245 degree. This is how to take the readings. Again, the properties of special angles. When we talk of special angles, the properties of special angles are useful in solving problems in bearing. The properties of special triangles are useful in the solving of bearing. What am I saying here? These properties are such as Pythagoras, properties of triangles, properties of triangles, like Pythagoras. We use Pythagoras to solve problems in the bearing. Pythagoras. We use sine rules to solve problems in under bearing. We can also use a cosine as well, cosine rule, to solve some problems under bearing. I want to talk briefly on the Pythagoras theorem, sine rules and cosine rules. Then you see how to apply these ones when you get to a particular problems under bearing. Let me start from Pythagoras. When we talk of Pythagoras rule, it means the triangle must be a right angle triangle. The triangle you are referring to here must be a right angle triangle. Take for instance, if you have something like this is a triangle. What do you mean by a right angle triangle? It means one of the angle in that triangle must be equals to 90 degree. Let's say this is equals to 90 degree. When we talk of A, B, and C, okay? A, B, and C. This is 90 degree. The hypotenuse side is our A, but angle B, where the capital angle B face is our small b, and where capital C face is our small c. This is how to name the triangle, any triangle given to us. The capital A, because this line is facing it, is a small a, while the other one is B. And the capital A is referred to as hypotenuse. Why? Because it's the side that is facing the angle 90 degree given to us. Any side facing angle 90 degree at any particular time in any particular triangle is referred to as a hypotenuse side of the triangle. While the other one will be either opposite or adjacent, depending on the angle you are referring to. So let's say we want to find angle side A. To find side A, then you will use Pythagoras here. Use Pythagoras rule, which says that A squared equals to B squared plus C squared. That means before you can say you want to find A, you must have been given the value of A and the value of B and C. Once you know the value of B and C, you will use it to find the side A using Pythagoras theorem. But in some occasions, you may be given the value of the hypotenuse and either A, B, or C. If you are given A and you are given C, then you can find your B using the same thing. If you want to find your B here, your B squared will be equals to A squared minus C squared. If you want to find B squared here, and then at the end of the day, you substitute to get your B. If you want to find C, it means it will be C squared equals to A squared minus B squared. These are the rules of using that you can use to find the Pythagoras at any given time. Then, apart from that, we can still talk of a sine rule. Sine rule. What do you mean by sine rule? Before you can apply sine rule, you have to talk of given angles. But if you want to apply sine rules means if you must be giving sine rule under bearing, then there must be what? A triangle. You must be given a triangle. Okay, this time around is not necessary to be in a right angle triangle. It can be obtuse or acute triangle. You can be given obtuse or acute triangle. If you are given any one of them, just name the side A, B, C. Okay? This capital A will be small a here because capital A is facing the side A. Capital B is facing this side of B, so this one is small b. And capital C is facing this one, this is small c. Now, if you are given the three sides and one inclusive angle, then you can use sine rule. The condition of using sine rule is that both you must be given either two sides and one angle, or two angles, one side. Once you are given two angles, one side, you can use sine rule. How? How do you apply sine rule? The rule is that A over sine A equals to B over sine B equals to C over sine C. This is the rule of sine rule. A over sine A equals to B over sine B and equals to C over sine C. You can apply this one in either acute or obtuse triangle. Either acute or obtuse triangle, as the case may be. It depends on what is given to you. It depends on what you arrive at. So whichever you arrive at, if you arrive at obtuse angle or acute angle, you can use sine rule to find any of these given side or angles there. So if you are given sides A and C, you are given side A and C, and perhaps you are given angle A, then we now say A all over sine A equals to C all over sine C, and then substitute for values. So at the end of the day, you're going to arrive at your answer. That's how to use sine rule in solving problems under the bearing. Again, we still have what we call cosine rule. You can still use cosine rule to solve some problems under the bearing. How do we apply cosine rule? Cosine rule. How do we apply this? This one is also applicable under any given acute angle. If you are given an acute angle of triangle A, something like this, A, B, C, we have C, A, B. Now, how do we apply the cosine rule? It depends on what is given to us here. If maybe you are giving value of A, side A and side B. You are giving side A and side B, then you must be giving angle C. If you are giving angle C, and you know side A and side B, then you can now say that using cosine rule, it means it's top of C squared, because you are looking for the small c. C squared equals to A squared plus B squared minus 2AB, and this is cos C. A squared plus, that is A squared, the value of this one, the square of it, plus the square of this one, minus 2 multiplied by this value, cos this angle. Then, by the time you substitute, you are going to arrive at the value of your C, which is now what you have to calculate here. But if it's the other way around, assuming you are given the value of B and C, you are given the value of B and C, and definitely if you want to use cosine rule, this angle was given to you, angle A. Then it means you have to find side A, and this gives us A squared equals to B squared plus C squared minus 2BC cos A. Or alternatively, if it is B, you have to say B squared equals to A squared plus C squared 2AC cos B. These are the rules of a cosine that you can easily apply in any given bearing. So these are the rules. These are the cosine rules that you can use. Alternatively here, if you are given side A, side B, side C without any angle, you can still use cosine rule to solve the problem. If you are given side A, side B, side C in a given triangle without any of the angles, then you can still use cosine rule. So this is another part of another way of using cosine rule. Another way of using cosine rule is, let's assume that you want to find angle A, not side A now. We want to find this angle. We want to find this angle A, and know fully well that all the sides has been given. Then we can now say that cos A is equals to B squared plus C squared minus A squared all over 2BC. This is the formula to apply. B squared, as long as you want to find angle A, it means all the three sides of this triangle must have been given. Then you now use this formula. the value of b squared plus c squared minus a squared all over 2bc. But if it is b, you want to find angle b, then it means cos b will be equals to a squared plus c squared minus b squared all over 2ac. Cos b will be equals to a squared plus c squared minus 2b squared all over 2ac. Now, we can still find cos c, which I will now do for you as an assignment. Find cos c in terms of this particular formula that I've given to you. Find cos c on your own. So if you can get get it right, then you'll be able to see that in any examination that you go for, it will be easy for you to use cosine rule to solve the problem. We are going to solve some examples here.